I felt the need to make this video because many times I read here and there people trying to make constructions in their garage with rear steering, and I thought that putting together some ideas and some knowledge I have, it's definitely a good thing to never do it because there are very few possibilities to use this way of steering without great risks. The preface is that I studied physics, some mechanics at school, at the university. I'm not a scientist, so if I'm saying something wrong, something that has got to be corrected, there is the comments list right for that purpose. I hope every criticism is constructive. So the thought about it is, well, let's draw a turn. Maybe better use something less thick. Right. Okay. With a vehicle running upon it in a turn. So here we have the rear wheels, 1 and 2. The wheels will run through the turn and the axle will pass through the center of the turn. Same will the front wheels, so when we have to draw them in their right position, they will be perpendicular to this green line. Alright, this is the car turning, car or pedal car, or we can think about a trike or a bicycle. Even a bicycle follows this criteria. Okay, now I'm gonna start with the word things. Yes, word, because it's a simplification for me to think better about how it behaves. Of course, we have a center gravity for all the vehicle, but now I'm thinking about cutting into, let's change color again, cutting into the vehicle and consider what happens to the mass in the front and to the mass in the rear. I mean, belonging to the front portion of the vehicle and belonging to the rear portion of the vehicle. Let's call 1 the front and 2 the rear. Okay. Now I hope I'm not gonna waste time writing formulas, but I have to because it's needed. Okay, how to check what the peculiar behavior, the specific behavior of the vehicle is? Well, I'm gonna make a comparison between the side acceleration, because if we have a speed of the vehicle, it has its own velocity running through the turn. We have centrifugal acceleration for the front and similarly for the rear. How can we express this parameter? Well, the acceleration is v squared. I mean, I will write for my own simplicity, for better expressing next. Well, let's do it again because I forgot an important thing. Okay, A1, the acceleration of point 1 is the speed of the point number 1 multiplied by the speed point number 1, that's what I was talking about, meaning squared, divided by the radius of the turn, easier to understand like this, of the point 1. I specified explicitly point 1 because both the radius and the speed of point 1 are different from point 2. Yes, because point 1 runs through this arc, and now I think I will change color. Point 2 runs through a shorter path. Shorter because if we think about keeping on turning in a roundabout, for example, the time for completing one turn is the same, so I will not divide between time 1 and time 2. Distinct, not divide. But both the radius and the speeds are different, of course, because even though I cut into the vehicle, the two parts are connected together, so the time to complete the full circle is the same, but the distance on a wider turn is longer. So I'm gonna keep on drawing, writing in another way the same formula. For example, let's take what happens in a full turn. We know that the speed is equal to space covered in a specific time. So I can write S1 by S1 divided by time per in this way it's okay, let's make it simpler, divided by radius 1. I'm gonna run out of free space on the screen because now I have to rewrite it again, because I'm interested in expressing the distance covered directly related to the radius. Yes, because for example, for a full circle we will have S1 is can be expressed as for a full circle 2 Greek p by the radius. Yes, so the full formula will become okay, let's make some room, otherwise I can't write. Right. 2p r 1 multiplied by 2p r1. Everything will be divided by t and everything will be divided r1. Now we come to the interesting part, because we've got r1 above the fraction and r1 below, so 1 can be taken away and the final result can be expressed as I have no room, so I will delete it and rewrite it. For Greek p squared r1 divided by time squared. So in the end, why did I rewrite this formula in this way? The interesting part is that A1 is proportional to R1, while time is the same. I mean, it's independent from what point we are talking about. So we can write that A2, yeah, it must be violet as well, is proportional to R2. What's the meaning, the final meaning of this? The meaning is that the centrifugal acceleration for point 1, in this case with front steering and in a turn, will always be higher than acceleration of the rear wheels. The obvious result is that any kind of vehicle with front steering is intrinsically understeering. I mean that the front wheels will tend to lose grip before the rear wheels. Is it a good thing or a bad thing? Well, it usually leads to stability and will make driving easier. Because if the front of our vehicle tends to drift out of the turn before the rear, no really complex maneuver is needed by our side to keep stability and safety. Yes, of course, if you see rally cars, you can see them drifting, but this happens because first of all, there are different geometries with suspensions, steering parameters that can alter the natural intrinsic understeering behavior. But of course, if you got a powerful engine unloading a lot of torque on the wheels, the wheels will not have to deal with centrifugal force only, so they will lose grip in various ways, and they can change the behavior of the vehicle to oversteering eventually. But intrinsically, if you think of a cartwheel made with 4 wheels and we just throw it in a turn, suppose that along the turn, it meets very slippery conditions, well, the front wheels will drift out of the turn before the rear ones. Okay, let's clear up some room. Let's make some room here, because there's something else I need to talk about before coming to a conclusion. Because what does it happen if we change the direction and the vehicle immediately has rear steering? So this A2 will become A1, and we'll have a new A2, which is the new rear, which is rear steering. Well, of course, the formulas are the same. So A2, in this case the rear, will suffer from bigger acceleration, centrifugal acceleration, than A1. Of course, this vehicle will always be oversteering, intrinsically oversteering. Well, at first glance, we may just think, what's the problem? If I feel myself, if I'm riding in a very slippery condition, I just counter steer and I will solve the problem. Unfortunately, this is not true. This is not true because if we take a look at what it happens between static friction and dynamic friction, something bad would happen. What am I talking about? If you have any object placed on any surface, now in this case I'm making the symbol of a tire, upon a new color just for fun. What color? Orange. On an orange road reminds me of something. Well, okay. On the road, the static friction is what we have when each part of the rubber of the tire hits the ground, does not slip in any direction, and then leaves the ground, the contact with the ground, while the wheel is turning. But if in the same moment when the tire, the big little portion of rubber hits the asphalt, it is drifting already because we are drifting away, the friction is lower. So if I'm trying to keep, if I can measure the side acceleration, the centrifugal acceleration, when the tire is not drifting away, I can reach a maximum value. Then when the tire starts drifting, the actual value will be lower. This is something that has been experienced. It is not just my thought. It's reality. So what would it happen if we counter steer? Let's switch to another color just to represent the tires. Okay, the car is going this way. We made this red arrow before. Now the rear side is drifting away along this direction, and we turn the wheels like this, because counter steering with a rear steering would lead to this position of the wheels. But the wheels in this case are 90 degrees to the direction. So if we need to keep to increase the friction, the grip of the rear tires, in this case we will lower it. The obvious consequence is that instead of correcting the trouble, we will end up in a full spin, uncontrolled spin. So to drag the conclusions, if I have a rear steering, I have a condition when the vehicle, no matter how many wheels it has, tends to oversteering, and as soon as it loses grip, it will end up in a spin unrecoverably. I don't think it's a good way to build, even though it may make a simpler, shorter transmission in velomobiles and bicycles, for example. But it is so dangerous, in my opinion, that maybe it would be fit for running at Battle Mountain in Nevada. Every year there's a maximum speed of HPV vehicles, but the road is fully straight, 8 kilometers of straight road, so the steering just is needed to keep the straight trajectory. But in all other situations, except if you have to go very, very, very slow, I wouldn't recommend it anytime. I hope this was helpful before someone gets hurt. If you have comments, ideas, please let me know. If I said something wrong, I'll be happy to correct. Thank you for watching.